Hello viewers, thank you once again for tuning in. Is your host none other than Mr. Spotter Fred. We want to continue doing what we like doing most. And now to information, just to say, the advanced financial management. Now friends, we have been doing investment decisions. Last time, we were looking at investment decisions under conditions of uncertainty. Now we want to look at special cases in capital budgeting or investment decision. So we want to look at the special. There are three special cases. One, projects with an equal lives. Two, we have apart from projects with an equal lives, we have the replacement decisions. Three, we have abandonment decisions. Now we start with projects with an equal lives. Projects with an equal lives. Projects with an equal lives. Now, in projects with an equal lives, it means that you'll have 2 or 3, 4, 5 projects to consider, but they don't have the same useful life. So there are more than one project with different useful lives, and this, for example, one may be having 3 years, 5 years, 6 years, another one 10 years. We cannot use just the conventional NPV. Conventional NPV alone cannot be sufficient criteria to evaluate the project, because one will have an advantage over the other. So in projects with an equal lives, there are 2 methods that can be used to evaluate these projects, because the conventional NPV alone cannot be the best criteria. So there are two methods used in evaluating projects with an equal life. With an equal lives. Which are these methods? A, we have the replacement chain method. The replacement chain method, right? Sometimes we call it the replication criteria. No, the replication finite criteria method, or we can call it shortest common time horizon, or we just use the least common method, LCM, something like that. Then B, we have the use of equivalent. We call it annual equivalent evaluation method, or rather annuity Npv method. So that's annual equivalent or annuity Npv method. That's the 2 methods. Now when you come to replacement chain method, let me start with this replacement. In replacement chain method, we use the LCM, whereby if, for example, the number of the project A has maybe 10 years, another project B has 20 years. What we do, we replicate the one with the 10 years, we replicate it by 2 to make it 20 years. So the first will have 20 and the other will be 20. To determine the NPV for the 20 years for the two companies. There is also a scenario where we may have, like, maybe one project is 4 years and another one maybe is 12 years. So we need to make a replication until that point in time the two projects have the same number of years. So a replication of two projects will be done such that the two projects have the same number of years. Then now we also talk about the annual equivalent annuity NPV, the ANPV, the annual equivalent, let me say annual equivalent NPV criteria. In the annual equivalent NPV criteria, we just compute the NPV for each project and we break it into several annuities. The NPV that we have calculated, we break it into several annuities. That is, we determine the NPV of each criteria of each project, and thereafter break the NPV to annuities as follows. Equivalent annuity NPV will be, you take the NPV, you divide it by the present value interest factor of an annuity, R% n years. Now friends, that means that if you have like 4 projects, compute that NPV. Then you split the NPV into several annuities by dividing it by the present value interest factor of an annuity. Then you can select the one with the highest equivalent annuity NPV as the best project. So those are the simple 2 replacement chain method. We assume that we are doing reinvestment. We are reinvesting the same cash flows over several years to in future. While the equivalent annuity NPV, we compute annuities. We compute NPVs and we break those NPVs into annuities. That's important. It's like, say, we compute an average NPV. An average NPV for at least 1 year, averagely 1 year. How much will be the NPV for each project? Then we compare them accordingly. Now, without wasting time, we'll want to look at an example. An illustration 1 in this area. An illustration 1 is that question you are seeing there, and it's saying, question 1, Kenya 1 Limited is considering the purchase of a new machine, which is considered to be cost savings. There are 2 machines on the market that are suitable for business. The 2 machines have the following cash flows. We have the low voltage and we have the high voltage. We have the year 0, 1, 2, 3, 4, as you can see. For low voltage, we only have year 0, year 1, 2, and 3. But for high voltage, we have year 0, 1, 2, 3, and 4. Then we have been told that the company has cost of capital of 10%. Required A, which machine will you recommend if the machine were independent? B, mutually exclusive. Then we also been told a machine using both the shortest common time horizon of time approach and the equivalent annual annuity approach, and advise the management. Now friends, from the required point of view, we have been told which machine are we going to accept if one, they were independent or they were mutually exclusive project. If they're independent, then you take all the projects if they have a positive NPV, meaning you can take all of them if there is funds available for that. If they are mutually exclusive project, then you take the project with the highest NPV, the most, the best NPV, because if you choose one project, these mutually exclusive projects compete for resources. So if you choose one, you abandon the other. So that's what we want to do. So I'll take this and say, example 1, we want to compute want to compute the NPV. And you know NPV, friends, NPV is the present value of the cash inflows minus the present value of the cash outflows. Then we accept or reject if the NPV is greater than 0 or is less than 0. Now we come to this other side. Then we continue and say, we have low voltage, and we have the high voltage. The discounting factor is 10%. The discounting rate is 10%. All of them. So we have the year 0, 1, 2, 3, 4. Then we have the discounting factor at 10%. Then we have, for low voltage, we have the present value of cash flows, and we also have the present value of cash flows. So we know that if it's 10%, this is definitely 1, and our initial outlay is 15,000. In figures are in thousands. And for high voltage is 22,500. Then we have the discounting factor, and the first year is just simple, and we have 0.9091. Then we have that 0.8264. Then we have 0.7513. We have 0.6830. Then the cash flows, we have the 6,000 by 0.991. 0.991. We have 5454.6. We have 0.288264 by 6,000. No, that one we've done that. 7,500. We have 6198. Then the third year, 7,500 by 0.7513. We have 5634.75, and this one was not there. So I can get the NPV directly there for low voltage, and that is 15,000 plus 54.6 plus 6198 plus 5634.75. We have the 2287.35. Then I come to the high voltage. High voltage, the cash flows is 7,000 the first year. 7,000 by 0.91. I have 63.7. Then the second year is 9,000 by 0.28264. We have 7437.6. Then we also have the 9,000 by 0.7513. We have the 761.7. Then the final year, we have the 7,500 by 0.683. We have the 5122.5. Then we are able to get that. So what would that be? We come and say 22,500 plus the 63.7 plus the 74.37.6 plus the 61.7. Then we have 5122.5. Now we have that one 85.5. So that is our NPV. Now we can answer this and say if they were independent, if they are independent, then choose undertake all the projects. Undertake all the projects, friends. But if they are mutually exclusive projects, if you undertake one project, you not undertake the other. So you select the best. If they are mutually exclusive, then undertake project, undertake high voltage, or buy the high voltage machine. That would be the best. So undertake high voltage, that would be the best machine. That's important. Now after we have done that, we now evaluate the project using the shortest common time horizon, which is the replacement chain method. We want to use the replacement chain method. We use the replacement chain method. Let's use the replacement chain method. So use replacement chain method. Replacement chain method, because we realize that one has three years and the other 4 years. So you cannot, NPV alone cannot really make a good decision, because you realize that the three may be having few years of generating sufficient cash flows, while high voltage has more years and it will generate more cash flow. So it may be preferred to the low voltage because it didn't have sufficient funds. It has enough time to provide sufficient funds to have a higher NPV. So let's prove whether high voltage is the best by using the replacement chain method. In the replacement chain method, one is 3 years and the other is 4 years. So we make the one with the 3 years, we give it a multiple of 3. And if you use LCM, so that's 3 by 4, definitely those are 12 years. So we have to give it a multiple of 3 up to 4 years. You know, if we say use of LCM, we know that 3 by 4 will be 12 years, and the other one will this is low voltage. The high voltage has 4 years, so 4 by 3 would be 12 years. So that's exactly. So the other one will give it a multiple of we give it 3 years but 4 times. The other one will give it 4 years but 3 times, so that we are able to have them at the same 12 years. So what we do, we come and say we have the low voltage. If you have 22, let's say the 2287.35, we know that if you move one, this you add the 3 years, you will be at the 6th year. Then you're going to move another 3 years, you'll be at the 9th year. Then now finally you move the final 3 years, you'll be at the 12th year. So how many 3 years are you adding? You're adding this. No, we'll want to know this. We'll want to know this. We'll want to know at the end of this. So if we are to compute, then we need to get the NPV for these items so that we get the total NPV. So plus this one, don't forget that. That means we are going to have the 1 plus r raised to n. This is the first 3 raised to the first 3. Then will be 1 plus r raised to the 6. So we have now added 6. Then this plus r then raised to 9. That means that our NPV will be 2287.35 plus 2287.35. We discount it 1 plus 0.1, right? 3. Then we add 2287.35. We discount it 1 plus 0.1, 6. Then 2287.35, we discount it 1 plus 0.1, and that is 9. So that is what we are doing, the 3 of them, we discount them. So we come and now compute that NPV here. We say we have the 2287.35 plus we have 2287.35 by 1.1 by 1.1, yeah, raised to negative 3 plus 22, sorry, I need to have a bracket there. We have 2287.35. You know, you divide 1.1 raised to raised to 6, then plus 2287, then we say 2287.35, then we divide by 1.1, yeah, raised to 9, then we close that bracket, we get the answer. That is 62. We have 67.08. That is our NPV because our figures were in zeros, in thousands. So that is our NPV, 6,267,080. That is for the low voltage. We do the same for the high voltage. We do the same for the high voltage. The same for the high voltage. Because this was the we were to give it a multiple of 3. There were 4 years. High voltage. For high voltage, the same story. 3185 was the NPV. So if you add 4 years, it will be the 8th year. Then you add another 4 years. 4 years. It will be the 12th year. So that's important, and that's what we wanted in order to rediscount our NPVs accordingly. So if we are going to rediscount our NPV, then we get the total NPV here. So simply, this is what we are going to do. Would be 3185.5 plus 3185. We are rediscounting this. 1.1 plus 0.1, and you know this is 4. This is the 8th year, right? These are the 8th year. Then we add this. Sorry, this is not the 8th year. This is the 4th year. Then we have 3185.5. So this one. We also bring 1.1, no, 1 plus 0.1, 8, like that. then we are able to compute our NPV. So we come and say that 185.5 plus that 185.5 1.1 raised to 4, then plus that 185.5, right? Saying that 185.5, then 1.1 raised to 8, then we close that, we have 6847.3. Let me put them in full. I'll say 299, because our figures are in thousands, so the full figures is 6847,299. So as compared to the low voltage, you have noticed now still high voltage is desirable. By using that, high voltage is still the best. High voltage is still the best after using that LCM approach. We have given it a multiple of 4, so that there was the first 3, like low voltage, there was the first 3 years, we added another 3 years, we added another 3 years, we made it now 12 years. So these are 3,339 plus the first 3 years that gave an NPV of 2287, so that make it 12 years. This one, we had that 185.5, which is already for 4 years. So we added another 4 years to make it 8. We added another 4 years to make it 12 years. And that's exactly what we did, or what we are required to do. So as compared to the low voltage and the high voltage, we still recommend high voltage. Now that is the replacement chain method. Replacement chain method. How about the equivalent annuity NPV? How about the equivalent annuity NPV? In the equivalent annuity NPV, we simply get NPV. We get the NPV over present value interest factor of an annuity r percent n years. And in this case, remember friends, our NPV is 2287. 2287.35. You divide it by the present value interest factor of an annuity, 10%. So 1 minus 1.1, no, 10%, raised to how many years are those? For the low voltage, I think I could have said this is the low voltage. For the low voltage, I could have said there are 3 years. So I raise it to -3. Then I have this, I divide that by 0.1. So I have 2.4869. Now that is for the low voltage. So I take 2287.35, then we get 919. So it is 919, because the figures were in thousands. I put it now in full figure as 777. So that is what you should get as far as the low voltage is concerned in in the equivalent annuity NPV. That is for equivalent annuity NPV. How about the equivalent annuity NPV for high voltage? Now for high voltage here, friends, you are going to take this and say equivalent annuity NPV high voltage. You are going to have the NPV over the present value interest factor of an annuity r percent n years. So what you do, our NPV is 3185.5. You divide it by the present value interest factor of an annuity. Present value interest factor of an annuity, this is 10%. How many years? It was 4 years. The other one was 3 years. So that 185.5, you divide it by, there is 1 minus into 1.1 raised to -4. Then I divide it by 0.1. So that is 3.1698. Let me say 89. This is 9. Then I will come and say that 185.5. Then I'm getting 1,004,932, because our figures were in thousands. So full figures will be 1 million. Now friends, you have noticed when using the equivalent annuity NPV, still the high voltage is preferred. That's a coincidence anyway. It could be otherwise, whereby the NPV criteria gave us an advice that is a high voltage. Using these other methods, it can be low voltage. But remember, the decision that is made by the low voltage by the replacement chain method should also be the same decision for equivalent annuity NPV. That is important. So in this case, we have noticed that there is consistency, and we have agreed that high voltage is the best. Now that comes to the end of this question. It comes to the end of this question, and it comes to the end of this criteria that we are talking about, the where we have many projects, especially two. There's a weakness with these methods, that the best, when you have at least two, you can use the replacement chain method to evaluate where the projects do not have the same useful life. And where you have more than two, you will use the equivalent annuity NPV is the best. You use equivalent annuity NPV in order to determine a series of NPVs and maybe select the best NPV, the best annuity NPV. So we've come to the end. It's very interesting, and we'll want to refer ourselves to a very easy question that was done in May 2012. So in May 2012, question 2, you can easily identify, you can do a question. That example, it was for one project was for 4 years, and the other project was 2 years. So you don't need to even replicate it into several years. You simply replicate it just once. The first project with the 2 years, you just give, because they are all even number of years. So 2 years and 4 years. So you simply say 2 by 2. You replicate it once, and you don't replicate the other project. So May 2012 is an assignment for you. Try it, and after you have tried it, you see the solution from our books manifested publishers. Thank you very much. I wish you the best, and see you next time when we'll be able to explore many other areas in these investment decisions. Thank you very much.